हॅलो हॅलो
ऐका ना, दीपक सर आहेत का?
आहेत ना दीपक सर, सांगितलंय तिथून दिसतंय ते बोलले जी Good afternoon, students. We will start the program after 5 minutes. At 1:20 sharp, we'll start our session. Thank you. Yes, good afternoon to all of you. Okay, so on behalf of IT department, I, Ketki Gauri, working as an assistant professor in PES Modern College of Engineering, Pune, welcomes you on for this webinar 2 under the. Hello, am I audible?
Yes, ma'am.
Okay, thank you. Under this webinar series on machine learning. So the next is I would like to request dear Ankita to give the introduction about this webinar series. Yes, Ankita, over to you.
Yes, ma'am. Thank you. Good afternoon, everyone. I, Ankita Chipade, welcome you all for today's webinar 2 on perception learning in artificial neural network with real-time example organized by PES Modern College of Engineering, Department of Information Technology. I would like to introduce our guest speaker, Mr. Tushar Kutte sir. He is the data scientist, researcher and trainer on data science, machine learning and IoT at MITU Research in Pune. He has completed his Masters of Engineering in Computer Science He has also written several research papers in national, international journals and conferences. He is also member of several review and editorial board of international journals like International Journal of Scientific and Engineering Research, etc. He was also program committee member of several international conferences like Third International Conference on Bioinformatics and Bioscience in Austria and and in many more. So without further ado, I'm welcoming Mr. Tushar Kute sir. Over to you, sir.
Thank you. Thanks a lot. So, am I audible clearly?
Yes, sir.
Yes,
Yeah.
Yes,
sir.
sir.
Yeah. Thank you. Thanks a lot. Thanks for the introduction and good afternoon all. So, my topic of discussion here is perceptron learning in artificial neural network. So, basically, we used to work on different kind of machine learning projects. We completed many projects on different areas also. So, one of the projects, one of the example that we have worked that I'll show today, and my prime aim will be to show you the meaning of perceptron and its usefulness in artificial neural network. Okay, so two parts of the session will be there. First, we'll be talking about the theory session, is theoretical background behind the perceptron concept in artificial neural network. Maybe if you heard about the same in a syllabus or maybe somewhere, so we'll talk about the same in detail. First part, we'll see the theoretical introduction to the same, and in the second part, I'll show you the practical implementation of it. Maybe if you are done again in Python programming, so we'll see the perceptron point of view, and if time is there, I'll talk about artificial neural network separately also, because ANN is an extension of perceptron concept basically. Okay, so we'll see the theoretical topics first, and then we'll see how do we implement the practical part of it. Before proceeding, just to note few things that knowing the mighty animal, basically animal we call in the world is the human being. How exactly it's possible there? Because of the brain the human being is having. Remember, we can do anything. Anything means most of the thing which other animals can't do. Why? Because of our brain. So human are having ability to identify patterns within the accessible information with an astonishingly high degree of accuracy. Highest, we can say, highest degree of accuracy that we have. And why it's possible? Because of our brain structure. So whenever we see a car or a bicycle, we can immediately recognize what they are. Anyone, not only we and you, anyone who is 3 years or 4 years old or 2 years old also is also can recognize the car or bicycle or many different kind of objects there. This is because we have learned over a period of time how car and bicycle looks like and what their distinguishing features are. Means how can we distinguish the car and bicycle? By knowing these features, we have learned how these objects are looking like. Not only that, but anything that you see, we are having brain and we can recognize them easily. We can easily identify the same thing. Okay, that's what the power of human brain is, and many things are present in the human brain. So basically, this human brain is the combination of neural network. It's a neural network. It contains the human nervous. I'll show you human nervous system. You can see this. This is the biological neuron present. I've taken this image from one of the biology book, so you can check it out. This is the single neuron, single element of the human brain present there. Just like if you see on a screen, if you see a screen, so what's a single element, single addressable element on the screen? It's a pixel. And if you combine the pixel, it creates that screen there. Correct. So millions of pixels will be there on single screen. So like that, it's a pixel in your human brain. And if you combine all these neurons together, there's a huge neural network is created. So in this is a single element. It's like a neuron. Okay. So how exactly it works? So see here, it contains some the nodes from where the data can be taken as input. Okay, so you can check it out. It's a biological neuron shown over here.
Uh,
Input signals. Yeah.
uh,
Excuse me, sir. Your screen is not visible if you are sharing your presentation.
Wait a minute. Yeah, is it visible now?
Not
No,
X.
sir.
Oh, I was showing it's sharing here. Now is it visible? I'm open my editor now.
No, sir.
It's showing it's visible. Okay.
The presentation access is there.
Yes, yes, yes. I have changed the setting.
Hmm.
Yeah. So now is it visible? Not. It's showing me it's sharing and turn it.
Because I have changed the setting also. Who can present? So everyone is presenting. Uh,
It's showing it's sharing again. Is it visible now? Not.
no, sir. Sir, can you join it again? Means you can leave the meeting and again you can try to join.
Okay, no problem. Now it's visible.
Yes, sir. Now it's visible.
Visible. Okay. Okay. Fine.
Yes. Thank you, sir.
Okay. Okay. So let's continue. So we are talking about the neural network, and now we can see the architecture of biological neuron here. It's a single element, just like pixel. I told pixel on a screen. So we are having a neuron in your brain. So this is a single neuron where we are taking the input from these nodes, like input signals are shown on the left hand side here, and we are having multiple senses. 5 senses are there. So that senses will take the input on different kind of things. So it'll take the data from this as the input. They are called dendrites. Dendrites are the nodes which are used kind of senses. Okay. And at the center of this neuron, we have a nucleus, which is the processing element, which perform operation on that respective data, and the extracted information will be passed to the second level of neuron or next level of neuron through the axon terminal. This is why we have axon, and then we have axon terminal, and to these axon terminals again next level neurons are connected. Next level neurons, one more neuron, again same nucleus will be there, again same dendrites, then nucleus, and then axons. Likewise, the large network is created. Now we'll be talking only about the single neuron here first, and then I'll show you how this huge network will be created. Now see, artificial neuron. So the concept of this neuron was proposed by Warren McCulloch and Walter Pitts. They published their first concept of simplified brain cell in 1943, almost 80 years ago, for the first time when the brain researchers started, and they have identified that this is a neuron. Neuron is an element which is present in human brain, which takes this input from multiple sensors, processes it, and then forward this information to the next level. So this particular neuron they called as the MCP, that is McCulloch-Pitts neuron. So they describe the such as nest cell as a simple logic gate with binary outputs. It's important to note that it contains the binary output. Binary output. So whatever data is taking will generate the data in binary format, 0 or 1, either yes or no, first or second, like any two digit. Almost variables are there. Out of it, one of the class will be predicted. One can be the output of it. So multiple signals that arrive at the dendrites and they are integrated into the cell body. If the accumulator signal exceeds a certain threshold, an output signal will be generated that will be passed by the axon. So if it is above the particular threshold value, first 0 will be generated, and if it is below the threshold value, 1 will be generated, or vice versa. That is what the first proposal given by the MacLuck and Pitts. Okay, so that's what the concept of neuron was started with. Okay, so using the similar concept, the artificial neuron was put in the research paper. You can see this one. This is what multiple inputs are there. We have a processing element present, and after that we are having the out, where again multiple outputs can be present there. So multiple inputs, multiple outputs, and we are having a processing element present in between these two. Now, using this idea of biological neuron, the artificial neuron concept was proposed. We'll see when it was proposed, but how it is relevant with the biological neuron there. So neuron basically it's a mathematical function model on working of biological neuron exactly in the same way. But the thing is that it is artificially created in the computing systems, and which is an elementary unit in artificial neural network. It can contain one or more inputs which separately weighted. Okay, what exactly the meaning of weighted is, that I will show you. Separately weighted, then inputs are summed and passed through the nonlinear function to produce the output. Here given nonlinear function, but for basic artificial neuron it was having a linear function. We'll talk about that also. What do you mean by linear and nonlinear functions? Then every neuron holds an internal state called as activation signal. Whatever data we get, so based on that data, what kind of output you have to generate, that will be specified by the activation signal there. Then each connection link carries the information about the input signals, and finally each neuron connected to another neuron with the help of a connection link. Let's see this. This is the novel concept using artificial neuron. A new concept was created by the Frank Rosenblatt in 1956 for the first time, and this concept we called as perceptron. So perceptron is a neural network unit, or we can call it as an artificial neuron. Artificial neuron is name given as perceptron that does certain computations to detect features or business intelligence in the input data. So like this was the first proposal in 1957. It was proposed like we are having some plane over here, and from that is taking a data first node. Okay, like that first layer, then it is passing ahead. Here we have the switches like the gates, then they are summed up together, and if that summation is going above threshold value, so first in output will be there, or if it is below threshold value, second output was there. Okay, this was the original perceptron which was proposed by Frank Rosenblatt in 1957. So perceptron is the computer-based representation of the neuron. That's what we call as the perceptron here. So perceptron was introduced by the Frank Rosenblatt in 1957. He proposed the perceptron learning rule based on the original MCP neuron. Same, that's what MacLuck-Pitts neuron was proposed. Biological neuron using the same idea, computer-based neuron, that is perceptron, was proposed. So it's an algorithm. Still it is used. It's used in the supervised learning now for the binary classification. So it's three things are mentioned here. Perceptron is an algorithm. So it's a computer-based algorithm today. I hope that you're knowing machine learning concept. Machine learning is something like we have the previous experience with us, and in that previous experience we have to fit your model. Okay, or you have to fit this data into the recently available models, and once it's fitted inside the models are trained with the given data, then we will use this data to do the predictive analytics on the respective data set. Okay, predictive analytics, we have to do the predictions on that. That's what we call as the machine learning. And predictive analytics or prediction based learning is called as supervised learning. Okay, and under supervised learning we are having again two different systems like regression based outputs or classification systems there. Regressions generate the output in continuous fashion. Numerical data, continuous data are there, which are where infinite number of possibilities can be there. And the second is classification system, where we are generating the output in the class format, like first class, second, third, or whatever number of classes are present. We are generating that, just like I mentioned about the cars and bicycles. So whether it's a car or bicycle, we are predicting out of it. It's called as classifier. So perceptron is a computing algorithm, machine learning algorithm, which is used for supervised learning, that is predictive analytics, and its output is binary fashion. It will generate either first or second output. Like so, this algorithm enables neurons to learn and processes element in training set one at a time. We'll see that how it is exactly performing the operation. This is what technical perceptron now being used in computing systems, especially for machine learning algorithms here. Now see, so artificial neuron and perceptron, the concepts are same, but how exactly the technical terminology of perceptron is used, that's we'll talk. This is the architecture of a single perceptron here. Okay, so we have the inputs provided here. Inputs, so like x1, x2, x3, x4 till x m number of elements are there. Inputs are there. Whenever you're getting a data, providing a data, so data contains some features, and these features are separately provided. Anything, for example, you are providing the features of the car, will be providing features of the car like mileage of the car, weight of the car, or whether what's a kind of fuel that car is using. Like these are the features of the car. So these are the inputs like x1, x2 till xm number of elements are there, and these values are having some random weight generated here, w1, w2 till wm. These are called as weights. These weights are randomly initialized, but they are adjusted afterwards. We'll talk about that. These are the weights. Then we have here the summation function, net input function, that's summation. So whatever input we have, that input is multiplied with the weight, and accordingly we are going to find the summation, means addition of all. Again, x2 is multiplied by weight, added x3, x4, x5, they are multiplied with the weight, and then they are added here. That all of them are summed up, they are summed up together at this particular point, and whatever value generated over here will be passed to the next node, which is called an activation function. So coming with the perceptron, perceptron is a binary classifier. It's a binary classifier. It means that it will generate the output either in 0 or 1. So here we have a threshold value, just like here the center point is threshold value. If the output generated is above the threshold, output will be first class, and if it is below the threshold, output will be second class. That is, can be 0 class or 1 classes are. Here we have 0 class, here can be 1 class. Threshold value generated here. This is the common idea of execution of a perceptron concept in computing system. But let's go in detail. How exactly the perceptron will perform the operation? See, the perceptron, there are two different type of perceptrons present: single layer and multi-layer. Single layer is a true perceptron, and multi-layer is artificial neural network. ANN in short we call it as. Okay. So single layer perceptron can learn only linearly separable patterns. See, what exactly task of machine learning is? Machine learning will build the model to do the classification, predictions of classification. So whatever data we have, based on that we'll build a model, and that model is having capability to generate or separate two different classes. What kind of feature first class is having, what kind of features second class is having. So based on that we'll separate it. Now single layer perceptron can learn only linearly separable problem. It means that when you plotted them on a two-dimensional plane, and when you draw a line between them, it's possible to draw a line, and that line will separate them directly. If such kind of problems are there, that can be solved with the help of a concept of perceptrons. And on the other hand, we are having multi-layer perceptrons, MLP, multi-layer perceptron, or we call them as feed-forward neural network, which contains two or more layers that have the greater processing power. Processing power is great, where we are having some n number of maybe thousands, lakhs, or millions of neurons are connected together, and where we require high amount of computing power. With the help of it, first perceptron can pass information to second layer will pass third layer to fourth layer, and at the end we will generate the final output out of it. That's called as multi-layer perceptron. So perceptron algorithm learns the weight for the input signal in order to draw the linear decision boundary. Linear decision boundary. So when you are drawing a line between the classes, so they can be easily separated. So this will enable you to distinguish between two linearly separable classes. Let's say first class is +1, second class is -1. This is just a class number names I have mentioned, +1, -1. Correct. So that's what perceptron will basically focus on to generate the output. So note that supervised learning, what we have talked about, is a machine learning used to learn models from the label training data. Label training data means we are having input and output both. Previous data, what was previously happened, what is your previous input, previous output, that will be given as input to the perceptron learning algorithm. and it enables the output prediction for future or unseen data. The data which is not seen, so it will be applied as input. It will predict what will happen next. That's what supervised learning will do. And perceptron especially is for supervised learning, and it's a classification will generate the class as the output. What is the class of the given input data present here? Now, this is what the perceptron basically does. Now, what's a rule present in perceptron's learning? Now, see, perceptron learning rules state that the algorithm would automatically learn the optimal weight coefficients. This one, the numbers which are multiplied here, W. The input features are then multiplied with these weights to determine if neuron fires or not. Neuron fires or not, it means that when neuron's value is above the threshold or below the threshold. If it is above the threshold, it is fired. It means it is given 1 as the output. And if it is below the threshold, it's not fired. It means it's giving 0 as the output. Like that will be possible. So here we have this. Okay, we are not talking about the 1 here. 1, if you multiply this W0 by 1, so as it is, data will be added here. That's what is called as bias in it. Okay, we'll talk about that also. And these are the weights. Number input is multiplied by weight. Again, second input, third, everyone. So practically, when you build the perceptron or when you build the artificial neural network, these weights are automatically initialized, randomly initialized first, and after that the adjustment is done. How this adjustment is done? Now see, here it was mentioned that supervised learning is a type of learning used to learn models from labeled training data. Labeled means we are providing input and output of previously observed data. Previously, what was observed? That's what we are providing. I have observed this was the input, this was the output. This is input, this is out. Like we have a series of such kind of observations with us, previous observations. And based on that, this perceptron is created. Okay, so these are the inputs, and it will multiply the weights, we'll get the summation, generate the activation function, and will generate the result. Now see, the result generated over here and result that you want, the actual result generated and the result that you want, that will be compared and will identify the error in between them. Okay, so here there's an error function created. So there are some settled error functions are there. We'll not talk about that in detail, but I'll show one small example how this error is calculated. Okay, so error will be calculated, will be sent back, and accordingly weight will be readjusted. Again, weight will change. We'll perform multiplication of weight and number, find the summation, then generate the output. If output is again still having error, we'll identify this error, weight will be adjusted, again sum up, again go ahead, again error, again go on using it, perform this particular operation there. This is what the perceptron rule is there. Okay, we'll see one example. I'll show you. Just a minute. See, for example, wait, I'll share the screen again. Okay, I think it's visible. It's visible. I opened my writer, my document. Okay, fine. Now see, for example, I'm giving input as 3 point, sorry, input as 3.0. Okay, for example, this is my input, which is provided as the input to the single perceptron, single input, like say x1 or x2, x3 somewhere. And I want the output as 9.4. Okay, this is my input, and I want this is your input, original data set. Original data set contains input and output both. So we generally call input as x and output as y. Generally, in the machine learning, these terminologies we use x and y. So x is the input, y is the output. That's what I want, and previously used observations are there. So in my case, x is 3.0 and y is 9.4. So as per the architecture of the perceptron learning here, you can see there's a one more value present here, which is multiplied and then they are summed up together. So let's say for the first time, when I created the weight will be 1.0, for example. Okay, so as we have seen, weight is getting multiplied and we are generating the result over here. So weight is initialized, for example, as 1.0. This is your x1, this is your w1. So x1 and w1, as I told, they are multiplied and I'm getting 3.0. Now you can observe that this is my generated output by this particular weight and this is my expected output. Okay, generated by my weight and input number multiplication 3.0 and my expected output is 9.4. So if you can see this, there's a difference between them. So we are having still difference of 6.4. 6.4 difference is present between these two. It means that this weight is not capable of generating the expected output. So the difference will be passed back. Means the error will be identified, will be passed back to the x again, to the previous layer again. This is what we call as the back propagation. This error will be passed back, identified, will be passed back. And again, as I told, weight will be readjusted. For example, weight is adjusted to 2.0. Next time, it is passing the error back. And again, I'm readjusting the weight. So 3 into 2 will be getting 6.0. Now you can see the error is decreased. Now the error is 3.4 between these two. Generated output and predicted output. Actual required output, sorry. Generated output and required output. So you are having now 3.4 difference. Again, error is present, will send back this output here. And weight will be readjusted 3.0. Let's say randomly they are adjusting actually. So 3 into 3, we got 9.0 series. And expected output is 9.4, a predicted output is 9.0. Now you can see again still the difference is there, 0.4 difference is present. Now we are decreasing the loss, decreasing the error which is present between generated output and the predicted output there. Now we'll adjust it again. Let's say 3.1. 3.1. So now if you multiply this, we'll get 9.3 here. 9.3 for example. Okay, fine. And expected output 9.4. Now still the difference is very small. 0.1 difference is present between these. This is the adjusted weight. This is the original input. Remember, actually algorithm is very complicated. Means lot many things are considered over there. I'm just simplifying the idea of perceptron because only for single input I'm showing. We are having x1, x2, x3, x4. Everyone is having weight. They are added, and after adding, then we are comparing with the required output. Like that's what we are actually having. I'm showing only single layer here. Likewise, we have multiple inputs. Second, third, fourth inputs are there. Then summed up together. Now we are almost close to the expected output. If it is not possible to generate the final output, then bias will be taken. Bias is the number which will be added, not multiplied. Added to adjust the value. So for this case, what is my bias? Bias will be 0.1. It means that you multiply by 3.1 and add 0.1, we will get this number. Multiply by 3.1 and add 0.1, we will get this number. Let's say this is just an example, simplified example I told. So this is the way it's trying to learn the weights, generate the result and check with the expected output. Again, readjust the weight, again perform operation, again generate the results. Like this is a process, this is an iterative process which is done in the perceptron. The perceptron learning rule will perform the operation to learn the weights, ideal weights of the respective input by iteratively performing this operation for multiple number of times. And at the end, when almost very small negligible error is there or 100% accuracy is there, it will stop. So my finally adjusted weight will be 3.1. So I'll be multiplying this by 3.1 and adding a bias. This is what we call as x0 basically. So add it and then I'm expecting this result. This is the way how perceptron tries to learn from the given data set. Let's continue the presentations now. Yeah. Okay, so now it's visible now. Okay, so the input features are multiplied with these weights to determine the neuron fires or not. Here we have activation function. Basically, see, I'm not given the activation function. So we are having the net input function where we are checking it, and based on certain threshold value, if it is above it, or below it, the neuron will be fired. Remember, see this. So what's perceptron function present? Perceptron is a function that maps its input x, which is multiplied with the learned weight coefficient and output value f of x, that is function that I'm performing on x, is generated. So like this, f of x is equal to 1, means output will be 1 if input is multiplied by weight and added with bias. So like in our case, what I told, x is 3.0, w is 3.1, and bias is 0.1. Okay, it is greater than 0. If it is greater than 0, output will be 1, and if it is not, it will be 0 output. So for this case, it is 1 output, and for this case, it is 0 output. Like that. This is how Perceptron tries to try to generate the classes based on the given input data. So here W is the vector of real valued weights. Real valued means these weights are floating point values. They are having the values in the continuous format with a decimal point present in them. B is the bias. Bias is an element that adjusts the boundary away from the origin without any dependence on input values. At the end, whatever the error is remained, which is unremovable, non-removable error is there. Okay, that will be added as a bias. So it will be adjusted finally. X is input of X values. You can see this. This is a bias actually. This one. This is bias because one is multiplied with this, so it's not having any effect. So one will be considered as input there. Whatever weight adjusted converted here will be directly added. It's not multiplied with one. It will be multiplied with one, but it is unchanged after that. That's why it is called as bias. So this bias will be added to adjust the final outcome here. Okay, so B is the bias that's considered over here, which is directly added here. This multiplication is having no effect in the output because if you multiply 1 by W0, it will be same. That's what B is present there. X is input values and M is the number of input to the perceptron. So all whatever number of inputs we have, x1, x2, x3, x4, whatever, all, for every input we are multiplying that input with the weights and finding the summation of it. Summation, we add all them together, just like on that example I mentioned there. I'm shown only single line, single input. Likewise, for every input, same operation perform, and all that summed up together, and that summation will be used further. So output can be represented as 0 or 1, or it can be represented as 1 or -1, depending upon which activation function you use. So basically 0 or 1. If you're having step function, we're using 0 or 1. ReLU function is there, 0, 1. Somewhere logistic function there, 0, 1. And somewhere we use hyperbolic tangent, that is tangent function, where we has 1 or -1 as the output. See, so perceptron accept the inputs, moderate them with certain weight values, then applies the transformation function to the output to output the final result. See that. So here we have the similar idea. So output will be in Boolean fashion, like 0 or 1. So that's what true binary classifier is there. The perceptron is having, which classify the data in truly binarized fashion there. Okay, so the Boolean output is based on the inputs, such as like for example, I'm having the data. I'm having the data about the customers of bank or any financial organization, and the person want to have the credit card, or he want to loan from the bank. So bank will have an algorithm. Bank will have a data features about the respective person, like whether he's salaried or not, and how much salary he's having, is married or not, what's the age of it, what's the past credit score that the person is having. These are the features. That's what we are having inputs. And what are the output possibilities there? Two output, yes or no, true or false, whether we have to grant the credit card to this person or not, whether we have to grant the loan to this person or not, yes or no. These two possible outcomes are that we are generating with the help of the inputs which are given here: salaried, married, age, past. I mean, this is just an example mentioned. So for all kind of machine learning algorithm, if you have observed, we are having a data set which contains the multiple features as input and one output. Multiple feature input and one possible outcome will be there. And with the correct combinations of the input data, will be predicting the expected outcome out of it. So that's what the inputs will be given to perceptron, and what kind of output we're expecting from the perceptron there. So summation function, this one, Epsilon multiplies all the input of x by weight w and then adds them as follows, like this. So this is what w0, the bias, 1 into w0. So 1 into w0 plus w1 x1, w2 x2 till wn xn number of inputs are there. Now, what is exactly the activation function is? Now, activation function used to generate the output either in 0, 1 format or 1 minus 1 format. So that will be the final output, means what kind of output you have to generate at the last node where actual output is generated. There we have the activation functions. So the activation function applies a step rule, which is converting your data into -1 or +1 format or 0 to 1 format, like to check if output of weighting function is greater than 0 or not. This is what three different activation functions are there. Whatever output you have generated, based on that, the first or second class will be identified. First kind of function, we have a step function, something like this. Step function. So in step function, either 0 or 1 output will be predicted. We'll be having either 0th class or class 1, something like this. Here, this is your input. If input is in this range, your output is 0. If input is above this range, your output will be 1. Okay, if you know the binary systems, it will be clear so much easily. X-axis we have input and y-axis we have output. Input here and output here. So whatever input you are passing, if it is constantly same till this t point, if it is going, t is the threshold value basically. If it is going above threshold value, it will generate the result 1. If it is below t, it is generating result 0. So t is the threshold that is identified, that is learned using the perceptron learning rule. If I am using a step function, and generally we are using a step function in core perceptron, in single perceptron we have step function. But if you have multi-layer perceptrons, when some hundreds of thousands of layers are there, when you are creating a neural network, that time activation function can be different. Which are that? We can have a sign function where we generate the result either in +1 or -1 format. Like when my input is negative, my result is -1. When my input is positive, my result is +1. Like that. Sign function will generate, or we have sigmoid function also. If you know the logistic regression, or there's a sigmoid function, what we say, 1 divided by 1 plus e raised to minus z minus input, whatever you are passing. That's what the sigmoid function is there. Sigmoid function will generate the sequential combination in this way. It's a sigmoid curve, logical curve actually. So output that you predict, that will be between 0 to 1, but not exact 0 or 1. You can see this curve is present there. We'll predict the value in this curve fashion, is having some exponential change. Whatever input you are passing, based on that output is changing. See, it's changing, the curve is there, that's why output will be different. But it will lie only between 0 and 1, and probability of having that data on the respective curve will be calculated. If it is above 50% probability, class 1 is predicted. If it is below 50% probability, class 0 will be predicted. This is what the sigmoid function is. Maybe if you know the logistic sigmoid function, the same function is applied there as an activation function. So for example, see this one, the same example that we have talked about, issuing the bank loan or not. Okay, so summation of wixi is greater than 0, then final output will be 1. Output O will be 1. It means that bank will issue the loan to the particular person. Whatever input you pass, Perceptron learn and generate the result. And if that result is greater than 0, it is issuing the loan. And if it is less than 0, else if the final outcome is, that's O is equal to -1, or it is below 0, will deny the bank loan. This is what learn using the perceptron. So step function can have that. It triggers the above certain value of neuron output, else output will be 0. So sign function output +1 or -1, depending upon the output greater than 0 or not. And sigmoid function generate an S curve which output the value between 0 and 1, 0 0.2, 0 0.3, 0 0.4, 0 0.85, 0 0.92, like that. But if the value is above 0.5, then it is 1 predicted, and if it is below 0.5, 0 will be predicted. Very large function, large functionality is present about the respective logistic function there. Okay, Wait, just a minute. Okay, fine. So this is the way the perceptron learns from the input data. So if you just check all of them together, my inputs are x1 to xn, my outputs are x1 to xn, but it's an output set present over there. So my output will be the possible combination between x1 till xn when it will generate 1 if the equation of your perceptron is greater than 0. It will generate -1 if it is not greater than 0. It will be 0. So still we have the weight here, which will have contribution of the input xi to the perceptron output, and w0, which is called as bias or thresholds. Bias value will be there, which will be adjusted, will be added finally to generate the result. So this will work on the data which we call as the training data. So if you know, in machine learning, training data is a kind of data which is used to train the algorithm, which is used to build the model. And once the model is built, we will use the data which is unseen by the algorithm to check what is the possible combination of output is present there. Okay. Now what we'll talk about the error. So error in the architecture diagram, we have seen this in perceptron learning rule. The predicted output is compared with the known output. That's also we have seen. And if it does not match, the error is propagated backward to allow weight adjustment to happen. Again, weight will be adjusted. So there are many different statistical functions present in artificial neural network which are used to find the error, not just like subtracting the data, not exactly. I just showed for simplicity, subtraction and then finding the errors. So there are many different functions, like binary cross entropy function is there, which is used to find the error present in the actual output and predicted by the perceptron. If it is not matching, then again readjustment of the weight will be done, and again go on learning till very less amount of error is present, or the error is now not possible to reduce, will perform the operation to learn from the given data set here. This is what perceptron decision function. For example, phi of z we will have actual linear combinations of two vectors here. Whatever number of input we have, okay, for example, having 5 inputs, so I will have a column vector, a vector of 5 elements here in x, x1 to x5. And similarly, we have another vector of w, we start from w1 to w5. Okay, and when you multiply the vector, so vector will be multiplied by, in just way, x1 with x y w1, x2 with w2, x3 with w3, 4 5, then multiplied, and based on that we generate the final output. This is what value z, that means possible outcome will be identified. So decision function will be done like that, x1 w1 plus x2 w2, like till xm wm. Decision function will be plus 1 if z is greater than threshold value theta, and it is -1 otherwise, like this, represented in the form of the mathematical representation here. Phi of z is equal to 1 if z is greater than or equal to theta. So z is the outcome of this multiplication that we get, and -1 if it is not greater than or equal to theta, it is less than theta, less than threshold value, then it is -1. This is what we call as perceptron learning algorithm. Single layer single layer perceptron we call, which are input is given, we learn from that, and we generate the expected outcome from that. One more thing to note, we I mentioned about the bias unit. For simplicity, threshold theta can be brought to the left and represented at w0 x0. See, it's mentioned here. W0 is okay, sorry, x0 is basically 1. It's not an actual input, it's a 1. That's why W0 will be taken as it is, and W0 is the value which we call as bias unit, which is directly added. Still is directly added. The same thing I mentioned here, not a different basically. Okay, so this is extra terminology added, which is used to adjust the final output, because it is not always possible to have the zero error. If error is not completely removed, then you have to add the bias to adjust it. So that bias will be there, which is W0. It's added, and final function will be created something like this. Will be created in this particular pattern. Okay, and final output, how is that? So initially I told about the same, that perceptron is a supervised machine learning algorithm which is used to classify the data which is linearly separable, binary output and linearly separable data. So it is used to find a decision boundary. See, this is what we are having, the wtx of it, and when the function is created, it will generate a decision boundary like this. For example, I have a data set with two features, x1 and x2, and two classes, the red one and the blue one, or the red minus or blue plus are present. The task of perceptron learning algorithm to find the perfect linearly separable decision boundary between these two. See, this is a decision boundary will be found. So the figure shows how decision function squashes WTX to either +1 or -1, and how it can be used to discriminate between two linearly separable classes. So here we have threshold value. This is your function generate threshold values here. If I'm going to predict now, if the value of x1 above this, my class will be plus. If value of x1 is below this, my class will be minus, like that. So decision boundary which is present between two linearly separable classes can be found with the help of perceptron learning rule. And in this first step function will be there. We have the it's a threshold value present here. Above the threshold, class 1, below the threshold, class 0 will be predicted from the same. This is how the perceptron actually works. So before proceeding with the practical part, I'll show the things practically how to work with the same. Just summarize it. So as I told, perceptron is a learning algorithm for supervised learning for single layer binary classifier, binary linear classifier. See, it's a linear classifier. In machine learning, we are having three linearly classifiers only. The first linear classifier is logistic regression. Second linear classifier is support vector machine, SVM in short. And the third is this one, that is perceptron, is the third linear separable linearly classifier, where we are going to predict the classes. We are going to build a model which is used to predict the classes either in 0 or 1 format. So let's see that. Okay, this is binary classifier. Optimal weights coefficients are automatically learned. Will learn automatically. Initially, they are initialized randomly, and after that, using the back propagation system, will try to learn the weight again. Then weights are multiplied with the input features, and decision is made on the neuron is fired or not. Then activation function applies to step rule to check if the output of weighting function is greater than 0 or not. Okay. Then we have seen the linear decision boundary. This one also. Linear decision boundary is drawn, enabling the distinction between two linearly separable classes, plus or minus one, like that. Any classes are there. I'm not talking plus one, minus one. You can have 0 or 1 also. And finally, if some of the input signals exceeds certain threshold, if output the signal, otherwise there will be no output present over here, like that. This is how perceptron learning is taken place. Now we'll see first thing about single layer perceptron, how to use single layer perceptron on dataset. I'm having a small dataset here. I'll share the link of the dataset also from where I downloaded. It's present in ML repository, that is UCI Machine Learning Repository. There, this dataset is present. Just a minute, I'll show you the same. And UCI ML repository. Just a minute, you can check this. How do we work on that? This is the UCI ML repository. Check this. I think the site is visible to you from where I have downloaded the data. So I'll show the data set. Just we'll go to the same. See, bank notes. Okay, I'm searching that bank note. This is your banknote authentication data set. Here I got this. See, on this data I'll show you how do we work with the perceptron learning data set. Okay, banknotes authentication. What exactly they have? See, here is mentioned. Data were extracted from images that were taken from genuine and forged banknote specimens. So two different notes are there. They have scanned two different kind of notes, genuine notes or forged notes, means original notes or fake notes. Two different kind of notes, bank notes are taken. And for digitization, industrial camera was used, for print inspection was used, and the final image was having 400 by 400 pixels. Okay, due to the object lens distance to investigated object grayscale pictures resolution about 660 dpi, and they have used wavelet transform tool to extract the feature from images here. Now you can see in the data set which was shown, it was having 5 different columns. When image is extracted, they have extracted the variance of that image, skewness of the image, kurtosis, and entropy of the image. See, four different properties of that image are extracted, and what kind of note was that, that's also extracted here. That's what the class we call. Now this data we have used to predict a new note is genuine note or forged note. It's a fake note or original note that you have to predict. So there is no any similarity among all the data. I'll show you that data set. There's no similarity present there, and if no similarities are there, then perceptron learning rule will be used. Like just I mentioned, four inputs are, these are the four input variables that we are considering for this algorithm, and one output variable, class. So as perceptron is binary classifier, this data set can be used for the binary classification, where outcome variable is 0 or 1. That is it's a binary classification system that we have, and four inputs will be there: variance, skewness, kurtosis, and entropy. This we will use, and based on that we'll build the perceptron learning model, which is used to predict when new node we are inserting in the machine. Okay, in the node counting machine, you might be knowing, will identify whether that node is fake or original, because if you see the fake or original node, their images are exactly same. But machine learning, perceptron learning, will help you to distinguish between the original node and the fake node. Okay, so if you go to this location, I can download a data set series. This one, data. It's a text file actually, but oh, it's not possible to post here. So you just can check it out. This data, so you just can go to Google and search for machine learning repository, from where you can work for the same data set, which is present in data folder. Okay, it's not possible to post me in the chat box, so just search for this repository. Okay, and you can get this information there. Okay, now we'll talk about the practical part, how it's possible to build the perceptron learning. I hope that you're knowing the core ideas of machine learning there, because it will take too much time. We'll directly go to the data set and perform the operations. So let's see. I'll open my Jupyter notebook here. Yes. So a new file I have created here. Yeah, it's visible, I think, now. Okay. Now, working with the machine learning in Python, maybe if you know, there are 2-3 different packages we require. So you can work practically in Anaconda also. In Anaconda, we have a Jupyter notebook where we can open and write the code step by step in for Python machine learning, and you can use Google Colab also, which is online cloud provided by Google, where we can work to create the project which are having the support for machine learning and data science applications design there. Now I need to open this file first. So to open or import this file, I can use the pandas package. Pandas is very commonly used package for structured data analysis. And inside the pandas, there is a function called as read underscore CSV. The file which you have downloaded, it was a CSV file. You can see this as in this particular function, df is equal to pd.read underscore CSV. This is my CSV file name. Just the data set which are shown there, which I'm opening, I'm reading the data set, and you can see this as given in the description of the data set. There are 4 properties of the banknotes were provided. By using the image scanner, these properties are scanned. You can see variance of data, skewness, kurtosis, entropy, and the class. Class 0 are the original nodes, that is, they are genuine nodes, and class 1 are the forged nodes, is fake nodes basically. If you observe that this all data, there is no any similarity present in that. It is one node is not same as that of second node, correct, third node or fourth node. But perceptron learning will learn to classify this particular data as per the architecture, as per the algorithm of perceptron learning that we have seen. Okay, so these are my 4 inputs and one output class of it. Maybe 2 classes are there. We'll see that whether actually 2 classes are present or not, that also we can identify from here. Okay, so this is my data set. I'll build the model of perceptron, and I will use this model to do the predictions whether a new node coming is fake or it is original. Okay, so this is a data frame. We have total 1372 rows and 5 columns are present inside it. Okay, so as a rule of machine learning, we have seen supervised machine learning, we should have labeled data given as input to it. So in perceptron learning also we have seen that labeled data is required. What is your input and what are your output? So generally, as a part of data science, we use x as the input variable, y as the output variable, which was shown in that document also. If my x is this and my y is this, then how can I create a relationship between them? So let's separate it. For example, I want the first 4 columns, 1 2 3 4, these 4 columns as the input. So I'll just take it. I'll drop the class column from here. Okay, and will be taken, and in y I'll take exact class column. So except class column, I'm dropping this class column, and the remaining data I'm taking in x, and I'm dropping the using the class column as it is. This is output variables. These are my input variables, input features, we call feature vector, and one, these are called as output variables. Okay, output labels. So features and labels, these names basically we use in machine learning when we apply the classification system there. Fine, input output are separated, so label data is required. Now one more thing to note, that I will build the perceptron learning model for this data to try to learn to distinguish between the nodes, fake and original nodes. But how do we identify that the model that I have created is perfectly working or not? How it's possible to identify the model that I have created is perfectly working or not? Now see, there are two types of data sets present in machine learning. We call them as training data and test data, which are used at various stages of development. Training data is the largest of them, largest between them, while the test data functions as a seal of approval that you don't need to use till end of the development. So what exactly meaning is training data in machine learning is actual data set used to train the model for performing various actions. Since possibly when you have to build the perceptron learning model, we have to use the training data, means some part of the data from, let's say 75% data I'll only use, 25% data I will keep it aside. So training data is the actual data, the ongoing development process models learn with various APIs and algorithm to train machine to work automatically. Okay, and testing data is the data typically used to provide an unbiased evaluation of the final that are completed and fit on the training data. So let's see this. For example, I'm having a data with me, something like this. This is a sorted data basically. Okay, so I hope that the complete, means whatever features we have or the connectivity that we are having between input and output is same. Okay, here these are the features. Feature 1 to target is 0101, something like that mentioned there. Okay, this is my data, original data set. Now what we'll do, I'm going to split this data in training and testing format like this. And by mixing all together, here we can see in testing data all are one basically. It should not happen. It should have mixed of 0 and 1 possible combinations presented there. So what I will do, I will separate 75% data in training, random 75%, and remaining random 25% testing data. Testing data I will not use to train the perceptron. I will keep it aside. Okay, I'll not use to train the perceptron. I'll use only 75% data, 25% data I will keep unseen to the perceptron model. So basically in all machine learning system, we use the similar methodology there, that we train the algorithm with training data, which is almost 75% of original data, and test data will keep aside. So we'll provide this as the input and we'll check that whether algorithm is generating the correct output or not. Okay, we'll build model on this data and we'll test on this. So see that the algorithm will be trained with the training data where x is input and y is the output. Correct. Once the algorithm is trained with the training data, the testing data, X-test data, will be given as input to the algorithm to predict the output. Remaining, which is unseen, algorithm will predict now the y-pred result, for example, which will be comparing with y-test. Y-test is the original output of this input that you are providing, which is not known to the algorithm, but algorithm will use y-pred, will predict it, predicted by algorithm, and originally we are having with the data that we are going to compare. I mean, how many number of entries are correct and how many are wrong? That's what we can find by using this. So by comparing predicted data and actual data, we'll identify how accurately the algorithm is performing. This concept we call as a cross validation. Algorithm is created, model is performed, model is created perfectly, but what about the performance? How the model is performing? That performance of the model can be evaluated, can be identified with the help of this concept of cross validation, where we generate the result by y-pred, we compare it with y-test, and how many entries are matching, how many are not matching, that's we can compare, and accordingly we'll find the accuracy score of the algorithm. We'll see that practically how to identify that. So note that for every machine learning algorithm, this cross validation is compulsory, by which you can check that the model that we have created perfectly working on the unseen data or not. Unseen data is the test data which is not used for training the model. It is just kept aside to test the model's performance. So let's see that we have to split our data in training and testing format. So check this. So in machine learning in Python, we are having a package called as scikit-learn. Scikit-learn. Okay, I'll show you that. See this. A minute. If you type in Google to check scikit-learn.org, this one, scikit-learn, machine learning in Python. So whatever the uh, algorithms that we are having in machine learning, all of their implementation is present in the class format in this package. So it's really predefined, built available in Anaconda in the Google Colab also. Okay, so here in classification system, you can see the Perceptron learning algorithm is present. Linear models, if you go, and in linear model we have OLS, ordinary least square, okay, or some regression technique. Many are there. Here we can see. Sorry, if it is present, here Perceptron is present. You can see this Perceptron. Perceptron, that's classification algorithm suitable for large scale learning. Okay, and it's simplified because it does not require learning rate. Many parameters are there in deep learning. This learning rate is used, not regularized, and updates the model only on mistakes. Means automatic learning is there. Means error handling is perfectly done. Correct. It's a perceptron. So perceptron is present as a learning model here. Linear regression model basically. Perceptron. Okay, remember that. And now let's use the perceptron. But before perceptron, we need to do the cross validation here. So to do the cross validation, there's a function called as train test split. We use model from sklearn, that is scikit-learn. Model selection, we are having a function called as train test split. So this train test split function is used to split your data in training and testing format. Okay, now let's see how to do this. Xtrain, Xtest. So two data I'm creating separately, training and testing separately here. Then Y train means X is input, Y is the output. And again, input separated in two format, train test. Output is separated again in the similar format. So test. So for train test split, provide the input as X, Y. Okay, what is your input? What's your output, which you are passing? And how much amount of data you have to pass to the training data, and how much amount of data you have to pass to the testing data. Okay, training data and testing data. That's what we are mentioning here output, but how much amount of data should be present? So let's say 25% data I'll store into the training, means whatever data I'm having, I think 1372 rows are present there. See, means 1372 entries are present. Out of it, 25% means 343. 343 entries will go in testing, and remaining 1029 will go to training. And there's one more concept called as random state. So to enable the randomization with the seed point 0. Done. Now see, I have mixed up the data, and 75% data we are kept in training, and 25% data we are kept in testing. If you just check this, 1372 number of rows are there in X, and if you see for X train, 1029 are there, okay, and if you see in X test, 343 are present. See, this is what the splitting we have done. We have kept this data aside to check the model's performance of perceptron learning, and this data will be using to build the perceptrons, okay, with 4 features. Only inputs are there. If you just check the snapshot of this data by using the head function, see this. This is your input data. And one more things to note, that only inputs are given. Another things to note, that data is randomized. These are the row numbers. If you check above, they are sequential, 0 1 2 3 4 till 1 3 7 1. But if you check this one, head is given, so first 5 entries, head means first 5 entries will be shown out of 1029. So you can see the randomization of it. Data is completely randomized. Okay, so it means classes are also randomized, because initially if you see the data set, here are 0 and then 1 are present, and if you split the data in continuous fashion, so almost all 0 entry will go into testing training, and only 1 will be going into the testing. So it will not be a correct algorithm created, correct model formed. That's why this randomization is compulsory. Correct. After that, we have seen this, how many entries are there in training, how many are there in testing, and see this, they are randomized and they are now available into training data. Now training data is the data which we use to train the algorithm. Now the perceptron learning will be done only on these 1029 entries. Now, as I shown in scikit-learn's linear models, we are having the perceptron learning algorithm. So there's a class of Python is present in scikit-learn's linear model whose name is